So how do we go about graphing these by hand? Now we've kind of seen what some of these graphs might look like. Let's graph r equal 2 plus 4 sine theta. So the key is we first graph this in the rectangular coordinate system, and we learned how to do this in trig. So this is going to be a sine theta graph. The amplitude will be 4, and then this plus 2 is a vertical shift of 2. So the graph would look like this. Normally the sine of 0 is 0, but we shift it up 2, and then from there we go up in the first fourth of a period to its maximum, which will be 4 higher than here, and since we shifted up 2 we're going to be at 6, and then we go back to what would have been the intercept, but we're shifted up 2, and then in the next fourth we go to the minimum, which is going to be -2 because of the shift, and then we go back. So what let's do is put each of these pieces, we're going to use the key points of this rectangular coordinate system graph to get the key points of the polar system graph. So first of all, at 0 we should be at 2. At 0 we're going to put on 2. And then what happens here? Well, as we go from 0 to pi over 2, we see that we increase to 6. So let's go from 0 to pi over 2 and increase to 6. Then we see that from pi over 2 to pi, we would decrease from 6 to 2. So in that next quadrant, we're going to start there at 6 and decrease to 2. Now, as we look at this graph and we say what's going on next, we're only going to go till we get to this intercept. So we see as we go from pi to 7 pi sixths, which we've got 7 pi sixths here in quadrant 3, we need to get back to 0. And then from 7 pi sixths, we see that we are negative r to 3 pi halves, and then till we get to 11 pi sixths. So this piece, actually let's just go to the 3 pi halves, and so we are going to go from 0 to -2. So as we're sitting here on 7 pi sixths, we start to do a negative r, so we're going to be up here in quadrant 1, and we're going to go until we get to -2 when we're at 3 pi halves, which will be around here. So it's going to look like that. And then as we go from 3 pi halves to this intercept point of 11 pi sixths, we go back to 0. So we're going to, at this negative, then we are going to keep moving around till we get back to 0. And then as we look at this last piece from 11 pi sixths to 2 pi, we increase again to get back to 2. And so what we just traced out here as we looked at the various pieces of the rectangular graph and put them on the polar graph was a limicon with inner loop. So the secret is not to try and memorize what these are going to be as much as be able to draw the rectangular graph from what you knew from trig, and then look at the key points and trace them out, and you will be able to see we kind of have the basic shapes here. We saw cardioid. Here is a limicon with an inner loop. We'll see some of the shapes, and you'll be able to kind of recognize those as you trace out these curves. Let's look at another example. This one we have 4 cosine 2 theta, and so we first plot that in our rectangular coordinates, and so we know that the amplitude is going to be 4 and the period is going to be 2 pi over 2, or pi. So at 0 we start out at 4 and we trace out the period in pi, and so here is one more period here. And so at 0 we're going to start out here at 4. And then we see in this first piece till we get to pi over 4, we're going to go to 0. So pi over 4 is right here. By the time we trace that out, we're going to be at 0. So there's that piece. And then from pi over 4 to pi over 2, we go out -4. So in this piece from pi over 4 to pi over 2, we actually are going to be down here in quadrant 3 because this is negative, and at pi over 2 we're going to be out -4. So as we get pi over 2 here, we're going to be down here by 4, and then we go back to 0 by the time we get to 3 pi fourths. From 3 pi fourths to pi, we see that we increase from 0 go to 4. So as we look at this angle, and here is our 3 pi fourths, and as we go to pi, we are going to go out to this maximum of 4, and then we go back to 0. So there's that piece. And then from 5 pi fourths to 7 pi fourths, we're going to go out to, these are negative again, and so even though 5 pi fourths is here, we're going to be up here in this quadrant. And we're going to trace out at 3 pi halves, we are going to be at -4. So when we're 3 pi halves, we're going to be up here at -4. And then we're going to go back to 0. And then our last piece from 7 pi fourths to 2 pi, we go back to 4. So we just traced out a 4-leaf rose. Some books call it a petal rose. I would have called them petals, but most of them call them leaves. So let's watch this. We are actually watching what we just did then live. We basically are tracing out the rectangular graph on the left as we're plotting this polar graph on the right and seeing the connection between the two of them. And there we got it. Now let's have a little closer look at our rose curve families. So if we have r equal cosine 2 theta, we did one with a 4 here. We saw that when we traced that out, we had this 4-leaf rose. But basically, let's go ahead and trace out that 4-petal rose. But this one would be, if we change that A in front, what it does is it affects how big these leaves are. And we'll go ahead and put that back to 1. Let's see what this n does, and n being this number here in front of theta. We saw when it was a 2 that we got 4 leaves on this rose. Let's go ahead now and let's make this a 3. Now that we have it a 3, let's go ahead and trace this out. And we see we still get it still called a rose, but it only has 3 leaves. So when we had n equaling 2, we got a 4-leaf rose. When we had n equal 3, we got a 3-leaf rose. Let's see what happens when we let n equal 4. Let's go ahead and trace this out. And as we plot these points, we see that we get an 8-leaf rose. So when n equals 4, we've got an 8-leaf rose. So can you make a conjecture? What if I change n equal 5? How many leaves are we going to have on our rose? Let's go ahead and see with n equal 5, 3, 4, there's 5. And then we can make an assumption here then if we have n equals 6, how many leaves on our rose? Yep, we're going to see 12. So very interesting in the rose curve families, if our constant out in front of theta is even, we get double that many leaves on our rose. If our constant is odd, we get n leaves on our rose, whatever that constant is. Let's go ahead and look now, and here we have just an interesting graph here. And when it's rectangularly graphed, this is what it looks like in its polar coordinates. We're going to see if we can pair up the numbers on the left with the key points on the polar graph, the letters there. So initially, where would we start? As we see this, we see that at 1, we are a little bit under 1. So that would be this point right here. And then as we go to trace this out and we see what the curve does from 1 to 2, we see that it increases to 4. When we get to pi over 4, we need to be at 4. So can you see where we would end up there? At pi over 4, we need to be out at 4. So you can see that 2 corresponds with B on our graph. It goes like this. Now, as we look at this rectangular graph from 2 to 3, we're going from pi fourths to pi halves. We see that it goes down through 0, and then it goes negative to -1 at pi over 2. So if we're looking here at pi over 2, we would have to be at -1. So that would correspond with G. So this point right here would correspond with G. And you can see if we trace that out, it would look like that. Now what happens between 3 and 4? Between pi over 2 and 3 pi fourths, we see that we go back to 0, and then we go to, looks like 2.5. So when we're at 3 pi fourths, we need to be out here at 2.5. So we can see that that point corresponds with point A. Now, as we go from 4 to 5, we're going from 3 pi fourths to pi. We again go back through 0, and then we go negative, and it looks like we go down as far as around -2. So at pi, which is out this way, we're going to be up this way. It looks like it's not quite 2, and because we were at pi, we went back here in the negative direction. So that one would correspond with point E. Now, what goes on between 5 and 6? Well, from pi to 5 pi fourths, we increase to about 2.5. So at 5 pi fourths, which is right here, we would be out here at 2.5. So that would correspond with point C. And then from 6 to 7, from 5 pi fourths to 3 pi halves, we decrease to -1. So at 3 pi halves, we're at -1. So we go 3 pi halves and go back in the negative direction. So that would correspond with F. And then from 3 pi halves to 7 pi fourths, we increase to 4. So we know at 7 pi fourths, we're out here at 4, and that one would correspond with D. We could trace that out. And then, of course, our last piece, as we get to 2 pi, we would be back in here to the one we started at, which was a number a little less than 1. So the secret is to look at the rectangular, put the key points on the polar, and trace those out. Kind of butterfly looking thing there. We can get lots of interesting shapes as we look at polar graphs. I hope you'll have fun with these. You will be left with some links, and I hope you go play so you can start to see some of the connections.